Welcome, everyone. All right. So today's webinar is the Changing Face of Human-Machine Interaction Applications webinar with Infineon. Today, you're going to learn how Infineon CAPSENSE solutions enable developers to bring elegant, reliable, and easy-to-use capacitive touch sensing functionality to their designs. So our speaker today is Brady Greiner. Brady is a product marketing manager for all PSOC 4 products at Infineon. He has a wide variety of experience in microcontrollers, connectivity, and security, and he earned his bachelor's degree in electrical engineering from the University of Minnesota. Today, we're also going to have some time for Q&A at the end, and we've got Vivesh Barathon, and a principal system engineer, and Brendan McAndrews, a staff applications engineer from Infineon, joining us today to help answer those questions throughout the webinar and then at the end. So you'll see them maybe pop up in the Q&A. So the first part of today's webinar, Brady will be walking us through a presentation, followed by a couple of demos of Infineon's CAPSENSE technology. And then we'll have about 10 minutes at the end of the webinar for live Q&A. So if you do have questions during the webinar, please write them in the Q&A panel. That'll be at the bottom of your screen. And the Infineon team will answer as many of those questions as possible before the end of the webinar. So I'm going to pass it over to Brady, and thanks for joining us.
Perfect, thank you. I just want to take the first second here to thank Hackster.io. We've actually worked quite a bit between Infineon and Hackster. We actually just got done with one of our contests with them, building AI for the IoT. We have a large community presence. As this group may be aware, we have 17,000 unique different products. What we'll be highlighting today is a subset of that larger portfolio. And Hackster and Infineon have worked really well together in the past, and certainly do in the future for new contests, and look forward to working with them. So, quick highlight of what we will be talking about today. So what is CAPSENSE? How does the technology work? Some sensor designs, right? Kind of showing how these sensors can be integrated into your end devices. And why choose us, right? We can tell you about the technology all day long, but why would you choose our solutions around it? And some physical hardware that this technology is enabled on. And then overall looking at our larger portfolio, rounding out with some of our software solutions and a couple hands-on demos, and then at the end, some Q&A. So with that, let's get started. So CAPSENSE is a proprietary capacitive sensing technology. We have been able to actually not only just look at touching interfaces, but changing how we interact with these devices, right? What you can see on here is a wide variety of different solutions of whether it's proximity applications, linear sliders, rotary buttons, mechanical trigger replacements. This technology came from Cypress Semiconductor that was acquired by Infineon in April of 2020. And with the entire portfolio that I mentioned, right, we can not only help you with touch applications, but we can start looking at how can you holistically change how your product interfaces with your end customer. When I had highlighted this a little bit on the previous slide, but what we can do and what we can enable with these with this particular technology is single button replacements in very harsh and reliable environments. We'll highlight that. Slider, to where you can have multiple elements and have improved granularity on sliding a finger back and forth. We can look at metal proximity, right, for how close a metallic surface can be to your PCB. Proximity detection, liquid level sensing. We can start looking at how hard someone is pushing against something, and then just absolute capacitance, right? Whether it's specific absorption rate, how close is an antenna, a radiating antenna to the face, or is someone present, right? Like in a car seat, we can detect if someone is physically hanging onto a steering wheel, sitting into a seat, things like that. We're actually #1 in the market. We've brought this technology out over 20 years ago now, in 2002. And we've replaced over 6 billion buttons, and we have over 100 patents that's associated to this technology, right? So this really is one of our defining characteristics within some of our microcontroller technologies. And we continue to innovate and show our leadership within this space. So I'm going to highlight some of the topologies on how this sensing technology works. So first one is I would call it the most basic solution, right? So this is what's called self-capacitance. Essentially, you have an emitter in the center, which you see highlighted in yellow, and that capacitance is then to ground or reference to system ground. And then what happens when you bring a finger in, you end up changing what that capacitance looks like. And then we read that information out, and then your application that runs typically on a microcontroller can define what that does. So this is probably our most straightforward application of utilizing capacitive sensing in a particular design. So secondarily, you can implement what's called mutual capacitance. So it's what you look at is a transmitter and a receiver side of your sensors. And when a finger or capacitive type interface comes in, you actually lower the capacitance that is coupled between the TX and RX, and we measure what that difference is. So when you have self-capacitance, you increase the capacitance to ground, and then when you have mutual capacitance, you decrease it because essentially you end up being a parallel path to that. This technology can also utilize inductive sensing. So what we do is we can have an LC tank circuit that has a particular frequency and amplitude that we work with, identify and work with you on implementing. And that inductor that is on your board ends up being a metal coil. And so as a metal target comes near and far from those magnetic fields, the amplitude will change, and we can detect what that looks like. We can have very granular information for that. So as an example, a metal overlay on a keyboard, on a touchpad, that can be more robust in outdoor settings. So again, as a high level recap, mutual capacitance is the capacitance from a transmitter and receiver electrode, and they can be utilized in different form factors. And then self-capacitance is from a transmitter to ground in your applications. I give this is a little bit of an eye chart, but what we like to highlight here is the different technologies can be utilized in different areas, whether it's metal detection, whether it's liquid level sensing, whether it's force sensing, finger touch. There are certain parameters that we can help you identify depending on what you're particularly looking for, right? An HMI application for an industrial environment will be completely different than a consumer environment or an outdoor environment. So we give this as a quick reference to kind of a directionality of what we would recommend for utilizing our Capsense technology for your application. So within our long experience of replacing buttons, right, we try to highlight some unique sensor designs that not only we can kind of give you as a starting point, but we can help you tailor for what you need for a particular form factor. Again, what we show here is both self-capacitance and mutual capacitance. And when you look to utilize these devices, we can vary the size depending on what the application is. In this case, it's an oven. So you do need to be fairly granular on, are you hitting the up or down button? Does it need to be a square feature or round feature, things like that. And we do have references that can be associated to that. We also have references for sliders, right, or rotational knobs. Some people may wonder how this is implemented. So we have certain segments that can then be associated to what's called a centroid, and we look at the capacitance between each one, and we can calculate where approximately where your finger is associated to that. And that can be in a linear fashion or rotational fashion. One of the unique aspects of our technology is that we actually have very strong liquid tolerance. Typically, liquid is conductive, right? And so that will change the capacitive reading in which your sensors would be responding back. So what you can see on the left is a water droplet versus a finger. And so what we can do is we can add what's called a guard sensor or a guard band and a shield electrode. And what that helps is eliminate the effects of what water would look like in these types of applications, and help highlight exactly when does a finger touch versus a conductive liquid that's on top. Because we are industry leading within the capacitive sensing, SNR readings, and immunity areas, what we actually have is industry leading proximity as well. So when you look at touchless interfaces, you can start looking at how a human will go to grab something or go to turn on something. You can think of thermostats, remotes. In this case, it is actually a paper towel dispenser, where it can up to 15 centimeters. It can start registering that someone is coming in to touch the area, and you can set the threshold at which something will happen. And all of this information is actually highlighted in our Getting Started guide with Capsense. Here we go. Because we've been in this space for so long, we understand most of the applications that people go into. We've highlighted a very dense set of collateral that you can utilize to get started using this technology. Not only the webinar today, but material, whether it's application notes, whether it's helping with sensor designs, whether it's the actual software tools, and or the actual hardware families of our microcontrollers that support this functionality. We highlight and give you very good material to get started. So why would you choose us on top of all of the collateral, right? A lot of times what we see within the HMI designs is there are challenges, right? Whether it's reliably knowing, is this a finger? Is this environmental? We are considered one of the best in industry for ultra low power in these types of applications for not only response times, but overall system power consumptions while people are looking for touch. We have very small form factor microcontrollers and solutions that can go be implemented into these designs. I think our smallest solution is, I think, a 2x2 millimeter area for the microcontroller itself. And then because of our improved SNR readings, we can actually have smaller sensor designs as well. As I mentioned before, the robustness aspect, whether it's liquids, thick gloves, temperatures, humidities, the actual external interfaces can be very robust going out. And then it's very easy to use. My background is actually a hardware engineer. And when hardware and software need to meet, that's where I'll say my fallings come through. And what we've done is we've been able to make this solution so easy to use that even myself can get out to market very quickly and reliably for your type of applications. And that helps with speed, time to market, but also you're not being frustrated in getting these solutions out the door. Excuse me. So with some of those challenges that we see within this space, why are we different? I had mentioned some of them while we were going through, right? But signal noise ratio, we have one of the industry leading high SNR ratings, which helps us have reliable touch. Very immune to noise. We can actually have multi-sensing, so we can have larger interfaces, whether it's more sensors, more complex sensors, things like that. Reliability and response time, and then to cap it all off, right, low power. Everyone wants improved low power type capabilities for the battery powered type applications. So within all 6 of these requirements, we thoroughly know that we are industry leading for our Capsense technology. with that, we've built out a wide portfolio, right? We know that some aspects or some customers need different types of solutions for their problems that they're trying to solve. So first on the left is our MBR type solutions. Excuse me. So they are configurable devices where we allow you to essentially click and drag exactly what you need for your application. It's very straightforward. It's one of our most user-friendly type devices that we have in our portfolio. There's no firmware development that's really required. So then our PSOC 4 and our PSOC 6 microcontrollers are full-blown microcontrollers where you have ADCs, timers, PWMs, normal GPIOs, things like that. And you have this reliable Capsense technology actually built into them. So our PSOC 4 portfolio and our PSOC 6 portfolio will be highlighted later in the slides. But what we are trying to highlight here is the vast breadth of different solutions that we have for what you'll need to go out to market with. And not only do we have the hardware solutions, but the software and support that's associated to it. Now that we're part of Infineon, we have great support, whether it's a community-based question and answer or direct response from our sales and support teams. We offer that holistic product support for you when you're doing your research and development. So as I had mentioned, we would highlight our portfolio overall. The blocks in orange have the what's called Capsense capability. The two in purple stars, the PSOC 4 and the PSOC 6, are devices that we're actively promoting here today. And what this goes to show is, again, the consumer and industrial total portfolio that Infineon has for microcontrollers, and then specifically what technology is enabled with Capsense. So with integrations and acquisitions, there is a lot of effort not only to have a single face to the customer, but from a sales and procurement perspective, but there is also from the research and development side. That being said, right, we have some legacy IDEs that we've historically had, whether it's PSOC Creator for our PSOC devices, or actually what's called Dave for our XMC solutions. And what we're working on now is actually integrating them into a singular solution with Modus Toolbox. So I'll highlight Modus Toolbox first. I'll get into Creator a little bit, and then we will get into our demos. So Modus Toolbox overall is looking to provide not only software and tools, but the community that can help respond to what information you will need, whether it's the tools from a project creator, library manager. We support a wide variety of IDEs. What comes in the box is Eclipse. However, we are extremely extensible to your development workflow, whether it's Kyle, whether it's VS Code, CLI, things like that. We can provide those instantiations for what you need in your for your application. We also provide configurators and tuners, and all of our stuff is open source, so it's all on GitHub. And then code examples, reference designs, we kind of highlighted previously. And then our middlewares. We actually have Wi-Fi and Bluetooth and security within our projects or within our portfolio of Infineon. So this is our single IDE that can actually cover all of those different spaces with our AirRock solutions, our USB controllers, our XMCs, and our PSOCs. What I had mentioned towards the beginning of that previous slide was development workflow. We know that you have defined a workflow within your environment that we want to be able to plug into while you're utilizing these technologies. So we've made it very extensible to be able to look at different industry standards to plug into your firmware teams. We also have these middle management library supports. As an example, we have what's called a library manager, and you can specifically choose and define what instantiation or what version of libraries that you're looking to use, so that when you go out to production, you can lock it down and specifically fine tune what you need to go into production with. And if something does go wrong, you can go back and look at the version control to try to build out a story around that. We have functional level APIs, whether it's higher level hardware abstraction layers or what we call PDL layers as well. We have different levels of API functionality for the next point, code portability. So we understand that some functions need to be very portable across applications, and then some functions need to be fine-tuned to what you need to do. Like, let's take a motor control application as an example. Those motor control algorithms need to be defined and refined moving into the future. And so some of your serial communications can be done at a higher level HAL layer, and then you can utilize PDL, which is a more efficient hardware abstraction layer that can help improve the performance of the microcontroller. So you can have this portability between your applications. With that being said, that was a lot of stuff. We have training videos that can help you get started. Whether it's actually the first 4 are PDFs that are, I'll call it training walkthroughs. So they help you get through different scenarios and different use cases of utilizing our microcontrollers and adding connectivity in as you work through the different training sessions. And then we do have software technical videos as well that help you not only be introduced to the Modus Toolbox ecosystem, but how to do certain instantiations as well, whether it's blinking an LED, PWM outputs, or GPIO interrupts. And the combination between these help you really start digging into what Modus Toolbox has to offer. I did start out that we are working on integrating everything into Modus Toolbox. However, the legacy stuff is not going away, right? PSOC Creator is still one of our founding IDEs, specifically for the PSOC 4 product line that I represent. So we do have material that not only highlights the IDEs, but again, does video tutorials as well that you can walk through. So I did leave a link on this slide that you can go back, and whether you are interested in PSOC Creator or Modus Toolbox, we have the training material to help you get out to market. This could be somewhat confusing, so we did try to highlight a quick where should you go, right? What is our recommended IDE as you're moving forward into certain solutions? Definitely don't hesitate to reach out, whether it's us as Infineon or Hackster.io. We can help you try to steer in a direction that you might need as this migration happens moving forward. But we did want to leave you a quick alignment of what IDE we would recommend depending on where in the hardware portfolio you ended up needing. So with that, I would like to move on to our hands-on demo. Our first one is going to be highlighting PSOC Creator and our PSOC 4 device. It will be about a 5.5 minute video that highlights what the IDE looks like, how to get a capacitive sensing solution up and running, and then we will hop into our Modus Toolbox in a PSOC 6 solution moving forward. So I will switch screens. Here we go.
My name is Alan Hawes, and this is PSOC 101. One of the coolest things you can do with PSOC is to detect the presence of a finger by sensing its capacitance. Put simply, PSOC offers the best capacitive sensing on the planet, and our Capsense component makes it really easy to use. All the Pioneer kits have sensors which we can use individually as buttons or combine together to create a slider. In this lesson, we will show how Capsense provides a very sensitive slider with just these 5 sensors. First, make a copy of the UART project because we're going to report finger position to the terminal emulator. Search for and add a Capsense component. Rename it and add a slider widget. Notice that by default, it has the name Linear Slider 0 and uses 5 slider sensor elements. You can design your boards with more or less depending on the resolution you need. As you'll see, with 5 sensors, we can easily deliver values from 0 to 100. Next, we pick the pins in the DWR. You'll need to use the PSOC 101 webpage for the pin selections for your Pioneer kit. First, select the CMOD pin. CMOD is an external capacitor that stores charge for the Capsense block. Then, select the sensor pins. Before writing the C code, you should generate the API files. In our C code, we can delete everything except for the UART start function and the global interrupt enable macro. Like Easy I2C, the Capsense block fires interrupts while scanning to update the internal data structures. Start the Capsense component. It is important that this line of code comes after the interrupt enable macro. This is because Capsense defaults to using an auto-tuning feature, which relies on the interrupts being enabled in order to set up the component correctly. Next, initialize the baselines. This zeroes out the noise and the parasitic capacitance on your printed circuit board. Then, run the scan-enabled widgets function to start the scanning process. This function returns immediately as the hardware block can do the scan in the background. In your code, you must only read the scanning results when the scan is complete, which you can determine from the isBusy function. In the main loop, check if Capsense is busy. If it's not, that means the scan is complete, so you can act on the results. The get centroid pause function takes an argument for the widget you are interested in. In our case, there is just one slider, but you could have configured several of them. The name of the widget is generated by the component and follows a formula. It starts with the component instance name, then the name of the slider from the customizer, which in this case is Linear Slider 0. But that has to be capitalized. Lastly, you append the type of widget, which in this case is the string ls with 2 underscores. The get centroid pause function returns a 16-bit value for the position of the finger. If there was no finger present, then it returns 0xFFFF hex. You're going to send a message to the terminal about the finger position now, but only if there was a finger position on the slider and the position had changed. The UART has a UART putString function that requires a conversion of the numerical result from the get centroid pause into a string. Do that with the sprintf compiler library function. At the top of the file, add an include of standardIO.h and create a character buffer for the string. Then make a call to sprintf in the main loop to copy the number into the string and append a carriage return and a line feed character. Once you have the string, just print it out on the UART. Lastly, you need to update the Capsense baselines using the update baselines function to correct for changes in the environment. Then restart the scanning process using the scan enabled widgets function. In the terminal emulator, you will see that you have very fine control over the value of the slider, even though it has only 5 sensors. For your challenge, I want you to replace the slider with a pair.
So, actually, what this is associated to is the previous lessons that I had highlighted. So this is lesson 13 out of, I think, I want to say 17 or 18. And so what he's referencing here is as the different lessons go forward, we help guide you through what these are. And this is a particular challenge. So the next lesson is he shows you how that's done. So what I'll do is I will pause the video here and I will jump to the next one. So what you saw was PSOC Creator and one of our PSOC 4 development kits. And I'll hop over to a Modus Toolbox and PSOC 6 development video.
All right, in this demo, I will be walking you through how you can quickly evaluate the Capsense buttons and sliders that are available on your PSOC 4 or PSOC 6 kit. We are going to use the Eclipse IDE for Modus Toolbox, which provides the Modus Toolbox software libraries and smooth integration with the Modus Toolbox software tools for configuring our target hardware. So to get started, we just need to quickly select this new application button here, and this will connect to our library of code examples that are available as well for free. And from here, we just need to select the kit that we are using. If you're using the CY8Z kit 045S, the PSOC 4500S Pioneer kit, you can select this BSP that I've highlighted right here. But today I will be using the 062S2 PSOC 6 Pioneer kit. And of course, we are evaluating the sensing. This is the touch HMI for Capsense buttons and sliders code example. So you go ahead and create that. I have already done it, so it is available in my Project Explorer for me already. So now that it is available, we can take a look at the README document that details all of the functionality and configuration of the code example. And if we look in the main.c, we can see that the code itself is actually not gigantic. And in the bottom right corner, you can see the kit that I have. If I touch one of the Capsense buttons, you see an LED turn on. If I touch the other one, the LED turns off. And if I use the Capsense slider, you can see the LED changes brightness based off of the position of my finger. So all of that functionality is implemented in this short segment of firmware. And to do this, we use the provided Capsense middleware API, like this CY Capsense scan all widgets and process all widget API or function calls that are shown right here. Since we're using the Capsense library with our project, the quick panel actually shows all of the tools that we have available, including a reference to the Capsense middleware library documentation. So we can go ahead and pull that up. And it looks like this. And basically this is an HTML document that details the functionality of our Capsense middleware library, including what layer of application programming that our Capsense middleware is expected to live in. One important thing is that the Capsense middleware library also includes detailed information about our Capsense data structure. So if you would like to know what is contained within the structures, we also have the structure definitions included in here. But the structures can be quite large, and we also provide a graphical way of configuring it in case you don't want to deal with manually going through and creating very large data structures. So let's take a look at the software tool for the Capsense configurator that is provided with the Modus Toolbox software. In the IDE, from the quick panel, you can just select the Capsense configurator and wait for it to load. And once it pops up, it reaches into your design.modus file to grab the existing configuration. And there we go. All right, so the configuration for the buttons and sliders is, perhaps as we would expect, 2 buttons and a slider. And you can see here in this graphical configurator, we can edit the widgets that we have. I don't need to add any, but by default, out of the box, we support buttons, linear sliders, radial sliders, and a few other widgets. You can configure the number of elements you have in your widget, as well as select if your widget is self-capacitive or mutual capacitive. In this case, we have 2 mutual cap buttons with 1 RX and 1 TX element, and we have a 5-segment linear slider. We can launch into this real-time debug using the Capsense Tuner. Launch the Capsense Tuner from the quick panel, and you will see the following window pop up. This is the Capsense Tuner, and the first thing we need to do to get started with it is connect to our kit. So to set up our communication interface, we select the kit prog that is available on all of the PSOC kits we'll be using today. Select the I2C interface and set up the port configuration as shown here before selecting OK. Once you've done that, you can select the connect and the start button here, and let's look at all of our widgets and electrodes right here. So now that we have enabled communication to the tuner, we can actually start viewing data in real time. So for example, when I touch the slider, we see a finger position show up on the linear slider widget in a graphical form. We also can do the same for each of the buttons, and we can actually look at the widget hardware values over here change one of these. Let's say I want to make this one 90 and apply it back to the project. And just like that, we've made a quick real-time change using the tuner. Additionally, the tuner provides functionality for finer granularity tuning. So if I wanted to look at just a single button and I didn't want to look at the processing for the widgets or the other buttons, I can do so in this graph view, which provides a stream of raw counts data. And here we can look at the raw counts in real time continuously. Additionally, we can perform a quick SNR measurement on any sensor that we like. So to do that, you just select the sensor, not the widget that you would like, but the sensor. Make sure nothing is touching it and acquire noise. And then you can repeat the same measurement, but this time touching the sensor to acquire the signal. And there we get a pretty good SNR of 13.74. Additionally, the tuner provides the capability to log data. So you just pass in a .csv file, select the number of sensors that or samples that you would like to take, as well as the data that you would like to look at. So for example, if I wanted the raw counts from button 0, I wanted 100 raw counts from button 0, I could simply select this box here, pass in my CSV file, and hit apply. Then during the runtime, while I'm looking at the raw counts data, I can just click this logging option, and that will append the newly gathered data to a CSV file. All right, so that is the quick demonstration, a high-level view of the Capsense software and tools provided with the Modus Toolbox software library.
Perfect. So to recap, today what we highlighted is what is our Capsense technology. We highlighted what the different sensing topologies were as the demonstrations went through. You heard them referenced a few times, self-capacitance, mutual capacitance, and what we didn't highlight was inductive sensing. We looked at how the sensors were designed, and you saw them again through these demos on our buttons and linear sliders. Why you would choose Infineon, whether it's our holistic portfolio, whether it's our fantastic support material, or our software solutions that go around it. We highlighted both IDEs that currently support Capsense, our legacy PSOC creator that still is still very utilized and referenced for material, as you saw within the training videos. And then our Modus Toolbox, where actually everything is starting to come together with our Infineon portfolio with security, Wi-Fi, Bluetooth, and microcontrollers. So with that, I think we can start hitting our Q&A sessions and look forward to hearing what you guys have.
Great. Yeah. So if you guys do have questions, remember you can post them in that Q&A at the bottom of the screen. I know we also had a couple questions that came in on the registration before the session started too, so we can go over some of those as well. So Babish and Brendan, were there questions that you wanted to start with?
Oh yeah. I think the first question that we have through the registration, we are using this technology to battle the addictions. Has it been used like this in any of the previous designs? First of all, I'm very happy to see this question. We are not only changing the face of the kind of more modern consumer products, but also utilizing the technology in a very positive way that influences people. So I'm very happy to see this question here. While Brady is presenting, I was looking at our the past design funnels and so on to see if this technology has been used in a particularly this application. I could not find a particular design. However, I will point out this, like the Brady said, right? We have replaced 6 billion buttons in the last decade. So it's nearly impossible for somebody to remember all of the design. And what I can say is that it has been used in the varieties of products, the consumer, industrial, automotive, and medical products, and so on. So that should give you some confidence that how resilient the technology is to use in a way that that is helpful in your design. And we did use this product or the capacity sensing for implementing proximity sensings for hygienic reasons, and you could find this in and there is a more this kind of technology is gaining more traction with COVID and pandemic, where majority of the people doesn't want to touch the public interfaces such as airport kiosk and shared printers in the office spaces and things like that. And we have also seen designs where proximity is being used in the medical applications, where in the surgical equipments and so on, that you don't want to touch because you don't want to create the stains and and bloods and so on the equipments during the surgery. So it's been used in the various kind of applications in the various ways besides the typical touch HMI. So that should give you some confidence on how resilient the technology is.
Yep. All right. So we also had another question come in through registration, and that was, can Capsense work in close proximity to sources of interference such as PWMs and LED or PWM LEDs? And the answer is yes. We have done many designs, of course, where there are plenty of digital signals coming into the chip, as well as a full Capsense solution, be it a proximity sensor, touchpad replacement, or just generic button replacement. And in those cases, we have high frequency digital signals with rather sharp edges coming in, typically in close proximity to the Capsense electrodes. On that note, there are, of course, some special considerations when you're designing a board layout that include high-speed digital signals near Capsense electrodes or sensor signals. And in our documentation, specifically the Capsense design guide, we cover a checklist of all of the recommendations that we have for reducing any crosstalk between those signals as much as possible. And some quick examples would be including things like a shield electrode, properly placed hatched ground, even series resistors of a low value on I2C lines to sort of curve out those sharp edges and reduce any high frequency or digital interference there.
Okay, I'll take the next question. Do Capsense require a specific PCB stackup? Is it possible to implement it using cheap FR4 two-layer PCB? So the first part of the question, do the Capsense require a specific PCB stackup? Yes. Can it be implemented using two-layer FR4 PCB? Yes. So again, going back to what Brady said, the 6 billion button that we replaced, majority of those designs used two-layer FR4 PCB. So it's something that we do and that we support and proven in the market in the last one decade. Now we support the sensor design in a single layer paper-phenolic PCBs up to a multi-layer PCBs, and depending upon which PCB that you use and what other components exist on that PCB, you might need to follow certain guidelines and follow certain requirements on how each stacks are or layers are utilized and what is on each layer right below the capacity sensor, to make sure that the interference from the other components and other layers are optimized or minimized. So those kind of design guidelines, the extensive amount of guidelines with examples and from the past designs can be seen in the Capsense design guide. I think if you refer to one of the slides that Brady mentioned, there is a list of collaterals, and if you look at the Capsense design guide, it covers the concept from the concept point of view, taking your sensor design all the way to production. And that includes handling, designing the PCB. How do you design for a single layer PCB? How do you design it for a two-layer PCB? How do you design it for a multi-layer PCB? And how do you handle if there are other components in the PCB? How do you, mitigate the interference, such as Bluetooth or LEDs and displays and things like that. So the short answer, yes, it can be done, and there are a set of guidelines how to optimize your design and achieve the best performance, and that can be found in the Capsense design guide.
Okay, so there's another question. about any difference in the capabilities of Capsense technology between PSOC 4 and PSOC 6 solutions. So that's actually, in general, many PSOC 4 products and PSOC 6 products share the same Capsense technology. However, some of our most recent PSOC 4 devices are launching with our 5th generation Capsense technology. And these devices are the, I think, PSOC 4000T and the PSOC 4100S Max devices. And otherwise, we all have, all of the PSOC 4 and PSOC 6 devices share what we call the 4th generation Capsense sensing block. I don't know, Babish, if you wanted to add any more specific detail about any differences there.
Yeah, I think what you said is correct. A couple of points that I would like to add with respect to the capability. Both the TET subsystem or Capsense subsystem in the both PSOC 4 and PSOC 6 supports same level of features such as button, slider, trackpad, proximity, etc. Those remains exactly same. And what you would find is that the APIs and our software tools to configure this Capsense, they all are nearly exactly same between the PSOC 4 and PSOC 6 portfolio. So with respect to supporting a capability on the end product, I think both devices provide the same. But within this devices, like Brandon said, there are different generations of technology. For example, 2nd generation and 3rd generation and 4th generation sensing capability. And some of the newer technology provides better or improved performance. So let's say 2nd generation, on a particular design, on a particular given antenna design or sensor design, it might give you 5 centimeter. But the exact same sensor design, if you use a 3rd gen device, let's say on a PSOC 4 or 4th gen technology, you might get about like a 10 centimeter. So right, so there could be between the devices, there could be performance enhancement that you could get. But with respect to supporting the interfaces, type of interfaces, both devices can support exactly the same. I'll take the next question. Infineon has a wide portfolio of Capsense products. How do I choose the right device for my product, and is one better than the other? So like I said just now, the TET subsystem is exactly same between all the portfolio of products. Now, then why there is a different types of portfolio and how do we use it, right? So if you look at the PSOC 4, it's a single core controller. And within the portfolio, you have the entry-level devices that support just the Capsense, and you could use that as a touch controller, right? Not to implement a button, slider, etc. Right? And then as the portfolio, if you look at the portfolio, then there are devices with a higher memory capability and other peripherals such as the SPI, I2C, timer, counter, ADCs, and things like that. So you could integrate more system functionality and implement, in addition to touch capability, you could use them to drive LEDs, you could drive them to integrate sensors and so on. But these are more of entry-level MCUs with a single core, right? So if your application demands touch HMI plus those kind of simple sensor integration, etc., then the PSOC 4 is the right device. Now PSOC 6 is a beast that has 2 cores, runs up to 300 megahertz speed, right? It can actually act as a host controller itself on a smart your wearables and things like that. So if your design is around and if you're looking for a host controller that has a touch capability, then PSOC 6 is probably the right device. The selection here is made not based on the capacity sensing technology, but on the kind of processor that you require on your design. Hopefully that answers the question. I'll take the next question. What level of support does Infineon offer to allow Capsense design, and how can I gain access to it? So first of all, we have been in the market for nearly 2 decades, and over the years being one of the pioneers and the first company to come out with this technology, we have seen how the technology adapted to various kind of segments, and with that journey, we have seen various kind of challenges that our customers faced in integrating the solution. So all of those learnings we have captured and created a comprehensive list of documentation called Capsense Design Guide. And this guide today talks about various kind of challenges that you might face and how do you attack or resolve those issues. So this guide takes you from the concept phase to how do you design a sensor, to how do you place your sensor in design, how do you design an overlay thickness, what kind of material, to what kind of challenges that you might face during the integration with other subsystems in the system, and what kind of production challenges, how do you control the yield, and so on, right? Including EMC, all that. So all of those are very well documented. So you have this huge list of supporting collaterals with respect to the documentation, code example, etc. We can also, and then you have our customer support, tech support, that who can review your schematics and layout and give you the feedback. The earlier that you get our feedback on your sensor design, better, because one of the centerpiece of the capacity sensing is that having the right layout and right sensor design is critical. So if our team can review your sensor design and give the meaningful feedback so that the performance can be optimized from the sensor. Besides that, we also provide simulation capability. If you wanted to estimate and understand how well your design will perform in the end application, end product, and will it meet your requirement, those can be simulated, and we can give you feedback on that. So those are mainly the two types of support that we provide. The first one you can access from our website. The second one you can access through the tech support. And Brady, you want to mention anything else? Community and
Sure. So not only that, from a dedicated documentation and working with Infineon directly, we have also established a community, whether it's through Hackster.io or Infineon as well. We both have communities that can help answer these questions. I believe we have over 400 applications engineers that monitor these questions that come in across our product portfolio, and we have dedicated experts that are able to respond back. So not only can people within the community answer, but those responses can be reviewed by our experts locally and give them upvotes. So as you go through and have, whether it's Googling a problem that you're having, we can help respond to those questions that you might have.
Okay, Brady, there is one more question. How is the general availability of the microcontrollers?
Sure. So from an availability perspective, we are significantly improving. Our PSOC 6 portfolio is on a 40 nanometer technology, and we are looking to improve throughout the first half of 2023, excuse me, to where we are supporting most of the demand that is coming through. And then for the PSOC 4 portfolio that I represent, we're on 130 nanometer technology, and we are improving significantly again, actually Q1 of 23, where we will be supporting over 75% of our demand. So working with customers and really understanding what requirements they have for ramping products, and then full production, we will be in a very good support, very good spot here in the next couple quarters. Perfect. So with that, I think we can give everyone a few minutes back of their day. I really appreciate everyone joining and listening to our presentation. Do stay connected with Hackster, as I believe we will be announcing a new contest here shortly. And again, thank you so much for joining.
Yeah, thanks, Brady, and everyone else for coming. We will be sending out a follow-up email later this week with the information about that upcoming contest and some of the stuff that was covered today too. So keep a lookout for that, and thanks for joining us. Have a great rest of your day.